Hi again. Our next presentation will be a case study given by Andy O'Connor. Andy holds an honor degree. He's an executive director at ERA Sciences. He holds an honors degree in science from University College Dublin and has over 15 years of experience in enterprise application lifecycle management in the life sciences sector. His career spans roles such as validation lead, QA IT lead, and program management with a focus on the 21 CFR Part 11 and the Next 11 compliance. Andy has led data integrity projects for GxP SaaS solutions and has expertise in risk management, regularly hosting risk workshops for clients. As an experienced LIMS and empowered practitioner, Andy is passionate about using Lean methodologies and design sprint techniques to help pharma and biotech companies achieve Industry 4.0 goals while driving process efficiencies. Andy, thank you very much for being here with us, and the floor is yours.
Thanks, Ariel. I appreciate the introduction. I can see my presentation is coming up there now. So hi, everybody. My talk today is on implementing and qualifying a GxP-compliant RStudio, or now POSIT, environment on AWS. And it's a case study based on our combined experiences working with Appsilon as well. So what I'll do is I'll go through the presentation and happy to take questions at the end. So this is just a bit of background about me. I've been in the pharmaceutical industry about 16 years now. Originally started off with a laboratory background and then worked with CSV systems with laboratory systems, transitioned to like global lab system deployments, and then eventually to more quality governance. So I'm going to present a case study today, and it's based on our combined experiences and how we've worked with Appsilon before in deploying a GxP-compliant RStudio instance on AWS, on Amazon Web Services. And it was for developing clinical studies for a life sciences company. We will show also, the case study is based on recent engagements, and we'll show also how qualifying the platform enables the development and validation of models in anticipation of regulatory submissions. So statistical software is often installed without GxP compliance initially in life sciences companies. And so historically, models have been generated on non-GxP platforms in early stage clinical studies. However, GxP decisions have been made, including regulatory submissions on these types of deployments. And this has led to questions on the accuracy of the study results during regulatory submission. And it causes questions about whether the tool is really working as intended, which is what the intention of validation is. So this has led in our experience to perform in retrospective or reactive validation with no sort of predefined approach to the system. It's just to get that instance kind of qualified in some way so that it can support a more robust submission. But this is kind of a reactionary approach. And it means that the software has no program of continuous validation. And it leads to a system that is kind of old. It's on an unsupported version eventually. It builds up this technical debt, and it's expensive to maintain. And eventually it just requires a replacement project. So that's been some of the sort of the experiences in our history. And it's great that we're all on the call today talking about, moving to the cloud and more modern methods. So here is a diagrammatic sort of representation of like the entire solution stack of like a statistical computing environment. And let's have a look at it from the bottom up. So on the base layer, perhaps originally it could have been installed on somebody's laptop even, or installed on some local servers. And that's the hardware then that contains the statistical computing environment, and it must meet minimum software requirements. And so generally the requirements are provided by the software vendor, and the hardware is made secure as well. So the next layer then is the operating system. So historically, from a validation perspective, it must meet minimum software requirements, again, be provided by the vendor, and of course be secure and protected by viruses. Then on the operating system, we have installed the statistical compute environment or the platform, and it must be installed correctly and operate as intended, again, from a validation perspective. And as an integrated development environment then for maintaining statistical packages. And then on top of those other layers, finally we get to build statistical models on it, and they perform complex calculations, and the accuracy of those results are really key. And of course, there's controls and safety mechanisms for storage as well to be considered. So you can see how if there's an unqualified layer in all of this stack, it can raise compliance and accuracy concerns downstream. So a lot of other talks are doing deep dives into the advantages of having statistical computing environments in the cloud. We're not getting into the details, the technical details as such, but I'll briefly give you a perspective from a more compliance perspective rather than a technical perspective. So historically, it was done on local computers, so it would limit flexibility and scalability, and you'd have to make sure that the computer is just not going to just give up the ghost someday. So when you shift to the cloud, then there's kind of new benefits and some challenges that emerge. So obviously, you're getting greater computing power for running more complex models. There's more centralized access for more distributed teams as our teams are maybe global in scope. There's more built-in redundancy as the model is on a compute environment that would have redundancy by default. And of course, then because when you're in the cloud, then you can have sort of faster model development cycles then, and it gives you all of the benefits that has been talked about today. But it does raise some compliance challenges as well. So it does mean that being in the cloud enables faster updates and changes to the system in the cloud. And from a validation perspective, that requires more work to make sure that it's operating and the changes are implemented in a controlled manner. When you put your infrastructure on the cloud, then the infrastructure is very much abstracted away, right? You know, when we install it on the computer, we know we can double click an installer and we know what's happening, whereas there's obviously more of a technical understanding required, and maybe the layers, the solution stack is somewhat more abstracted, and it requires very deliberate configuration then on the client instances. And sort of pointing to the infrastructure as cloud that Raphael was talking about earlier. And then there's maintaining compliance across the entire solution stack as well. Can be a bit more challenging if it's abstracted and we don't have a good understanding of what that looks like. So our case study to install RStudio on AWS had a client need. It was to develop the RStudio compute environment for model development. The main objective was to provide a fully qualified RStudio platform on AWS, which would enhance reproducibility and compliance for modeling, for clinical modeling. So the platform in of itself was installed as a qualified instance, and then model development was performed afterwards. And the secondary objective then is to recognize that when the infrastructure stack can change, that implementing infrastructure as code then sort of enables that efficient future updates, because you can clearly see exactly what version the stack is at and where everything is. So the approach steps are as follows, and I'll give you a run through of the approach on a very high level in a number of steps. So the first step was that the platform is labeled as GAMP Category 1. If anybody doesn't know what GAMP is, it's good automated manufacturing practice. It's good practice guidelines to meet 21 CFR and Annex 11 considerations. And it's a tome of guidance for implementing many different softwares and automation in a life science environment. So GAMP5 is quite commonly referenced and quite commonly seen around as guidance. So we provided a snippet here of what it says about category 1 systems, and it's just a label of a category of systems. And you'll see that when you read that snippet of guidance that is from GAMP5 and referenced below, that it includes statistical programming tools. And so that's quite an interesting perspective from delivered from life sciences guidance. And so we've leveraged that here as part of our approach. So that was the first step. The second step then is that the validation approach is defined, and we're getting into our more nuts and bolts of validation and compliance, where a validation plan is created and then we outline exactly what we're going to do. So we get to see at that point what the platform requirements are, detail those, and then take it forward from there. So the third step then, I mean, this is very much the compliance steps. So there's kind of like a technical shadow step here, obviously, that's what most of the presentations are about again, which is that there's some sort of initial instance where the build is figured out, exactly what kind of platform we're going to build on, and whether it be AWS or Azure or wherever else. Exactly what that solution stack is going to look like. So there's a lot of technical development that goes on, and eventually when that's understood and there's kind of like an unvalidated environment, that a proof of concept set up, then eventually we go into installation. And installation is performed on AWS infrastructure, and it's performed in a controlled manner through installation qualification. Anybody from a validation background will understand that'll be more common. So it's kind of like an installation script to install it in a controlled manner. So there was, as part of the installation, the use of Kubernetes, and there was a cluster on AWS, and basically the installation was performed via infrastructure as code. So infrastructure as code was used as the YAML file to define exactly what that installation looked like. And that was part of the script. And it was implemented in real time then and recorded and controlled. And so that really gives really fine-grained control over the platform's infrastructure, and it maximizes the reliability and compliance then. So once we have our platform installed and it's sitting there ready to go, then there was operational qualification that was performed on it, which is a common expectation. So we run based on the requirements. We make sure that the system meets our requirements that we've defined by running some testing on it, to more so from a compliance perspective, make sure that the system is meeting client need and meeting all functional requirements. So once we understand that the system is working as expected on our solution stack, then and only then is the qualified RStudio environment released to the developers for further model development. And there's still a big step to go then after the models are developed. They have to go through their own life cycle, right, where they need to be further validated then, depending on their usage and whether they're labeled as GxP or non-GxP. And this is all as according to client SOPs. So from the simple case study that was presented, the takeaway is that separating the platform qualification from the model validation provides this sustainable, scalable approach to compliance, which historically hasn't been implemented in this way. So historically, the compute environments, the enablement project is typically performed in 3 to 5 months based on our experience. And by qualifying the platform up front on a cloud environment, then clients now have a secure and validated infrastructure that allows the clinical team then to focus on modeling. Whereas before, if it was installed on their local machine, there would have been accuracy considerations throughout the whole solution stack. And these business teams then are enabled to and empowered to focus on model validation at the right time for regulatory submissions, and they don't need to worry about where it was installed, when it was installed, and all the rest of it. Platform qualification addresses concerns about the tool's validity and accuracy throughout the solution stack. And again, the stack demonstrates that there's a fully qualified foundation there, and this frees up the business teams to really focus on what they know best, which is their model and model development. So let's have a look at the stack again. This is our solution stack as before, and it shows the qualified layers in the stack upon which that model development can occur. So if we look at it from the bottom up, infrastructure is now delivered on AWS, and that's delivered via infrastructure as code, qualified to the client's validation processes. The next layer up is the operating system, also delivered via AWS, and we know it's well controlled there. RStudio then is installed on the AWS instance and operates as intended. And it's worth noting that the vendor was also audited at this point, or vendor qualification can occur. So it means you're not really sort of thinking about those considerations late stage into your model validation and development. That's all sort of cleared up beforehand. And only then, once you have your qualified environment and your solution stack as a category 1, then you move on to your statistical model development. And it can be built as needed and the performance checked as needed. And that's to confirm accuracy, and a risk-based approach can be further used then in your model. So that's the case study in a nutshell, really. For anyone interested in deploying a GxP qualified RStudio instance, now POSIT, you can reach out to the following. And thank you for listening. I'm happy to take a couple of questions. Cheers.
Okay, so thank you very much. That was a very nice talk, and also has been very connected to many of our previous presentations. There's a question that was asked on a different channel by Leonard Sampson, and he said, can you give examples of tests or procedures that you run for operational qualification?
It really is kind of a case-by-case basis at that point, because it's and it's a difficult question to answer. I mean, it really depends, and it's because when you're doing any sort of retrospective validation, which is not really recommended anymore, it's that you're taking the model into consideration along with the entire stack. And so that's where the benefit is. If you can split your model from your platform, you can do your model, get that pre-qualified, and then you're just worrying about the model validation, and you're able to sort of label your model, understand sort of what the use of it is, whether it's GxP, non-GxP, and then do sort of a risk-based validation on it. So if you're looking back and doing a retrospective validation, you kind of have to work backwards on that, and you have to understand your model use. And then you also have to work backwards through all those layers. So it can be quite complex to do a retrospective validation.
All right. So while I see, while other people is asking more questions, let me ask you once. Because, yeah, you mentioned at the beginning of your talk that in the past, companies were installing the software without doing the validation, and then they were doing the validation as required, and that created troubles, and I agree. And so one thing that is important is when you look at the long term, and you also mentioned that there will be a lot of updates might be in the different layers, can be in the operative system, can be in something more specific like R version and so on. So it's not it is important as well for the developers team to have this coordination with the platform team, so you don't find that, for example, some application, and as a company you want that your apps stand for a lot of time. You don't want to find the situation that your apps has some requirement can be our version that will be no longer supported. How to manage this in these new conditions of using the cloud?
So if I understand the question correctly, it's that there's a lot of coordination goes on in the cloud, and that when you install a system locally, that coordination doesn't happen. So how is that managed? And historically, I don't think it was. I think it was very challenging, because if a statistical software package was installed, or platform was installed on, say, a local machine like a laptop or even a desktop back in the day, that it was kind of locked into that version, and it would be very difficult then to update that to a newer version. And it's somewhat challenging then, because the model may sit on the same machine, on the same machine as your software instance. And so when you try and update the software instance, you're kind of worried about whether there's going to be a clash there. And so it was always very arduous. And as a result, it would cause a lot of the local machines to remain on a lower grade version. And people would be very, very reluctant to update the version, because they'd be afraid their whole model would break. And so you just see that it's just be these machines with very, very historical platform versions on them, which is not ideal.
Yes, thank you. So I think there are no more questions. So please, everyone, give a round of applause to Andy. Thank you very much. And if there are more questions, ask him directly or put them later in the chat.
Perfect. Thanks, Ariel. Thanks, everyone, for listening.